Okay, so starting back with arithmetic sequences, we have our definition. Remember that you build on it by adding or subtracting a value. We have two different ways that we can show that. We can use an explicit function rule where we just plug in the number for any term and it will give us that value. Or we can use a recursive function, and that means that we have to take that first term and build off of it step by step, so like building blocks. So our first example, we have a sequence here, and this is just saying a sequence of k, sub k, where k starts with the first term and there are only 4 terms. So you see this is our set of our sequence. It's 1, 4, 7, and 10. We know that there are only 4 terms here. If there's a set amount, then that means that it is a finite sequence, just meaning that it does have an ending value. When we're talking about a sub k, that's whatever term number that is. And so our term numbers here, this is the first term, so we would note it as a sub 1. This is a sub 2. This is the third term. And this is the 4th term. So that's just how we write that notation down. Let's first talk about doing an explicit rule for this sequence. We would state that, let me write this as explicit. So we go ahead and state our sequence. It's a sub k, where k is the first term, and we've got 4 terms to go. And so with, and we're going to talk about finding whatever value k is. We can tell our pattern here is adding 3. 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, and that's the end of our sequence. So whatever term we need to find, we're going to take 1, and our common difference was 3. That's where this 3 is coming from. And we can multiply that by the term before it. So to show the term before the term k, we would have to subtract one of the terms. So if I'm trying to find term 4, I'm going to use the information from term 3. So 3 times 3 is 1. I'm sorry, 3 times 3 is 9, plus 1 is 10, and so that's how we get that value for the 4th term. If we would do the same thing if we were trying to find the 3rd term, then we would use 3 as k, and then that means that we would substitute 3 in for k here because we are trying to find that term. 3 minus 1 is 2. 2 times 3 is 6, plus 1 is 7, so you can see that the 3rd term is 7. So this one is explicit, is used, you can find any term without having to know the entire sequence or build all the way up to that term. Let's say if it has 100 terms, it's a lot easier to plug in a number between 1 and 100 and for k to find that value than it is to count every single term. Another way to write this is like as a function, a of k is 1 plus 3 times k minus 1. It's the same thing. It's just a different notation. Then we have a recursive. Recursive means that we are building it term by term. And so what that's going to look like, let's talk about our sequence. It's still 1 term to 4 terms. We want to state or define our first term. So a sub 1 is our first term. That's what that 1 stands for. And in this sequence, it's the number 1. And then we're going to go ahead and say, well, if I want to find term k, then I need to find out what the term before that is. To go before it, you would take k minus 1. And I'm building this sequence by adding 3 each time. Okay, and so we take whatever term we're trying to find, we need to know the term before it, and then add 3 to it each time. So let's look at a different example. This example is for a function that or a sequence that continues infinitely. So this is what we would call an infinite sequence. We've already defined it here that a sub k, where k is the first term, and then there's infinite terms in it. And we've got 3, 7, 11, 15. We can go ahead and talk about what's happening in the sequence, how are they building it. We are adding 4 each time. So if we wanted to talk about or create an explicit rule, we would define that set. So we have a sub k. We have the first term, and it has infinite terms. And we're going to say with any term, we would start with what it starts with. So this one, the first term is 3. So we're going to put 3. And we're building it by adding 4 each time. So that's our common difference. So we're going to take our common difference times, and remember we have to use the term before it. So this is going to be k minus 1. If we are talking about our recursive, then we would still define the sequence the same. It's a sub k. K is equal to 1. It's an infinite sequence. We want to define our first term. So a sub 1, the 1 stands for the first term. Our first term in this set was 3. And to build on this, for any term, we would take a sub k, so the kth term. We would need to take the term before that, whatever that term is. So if we were finding k, then it would be k minus 1 for the term before it. And it's building by adding 4 each time. So then we use our difference here. So explicit formula, 3 plus 4 times k minus 1. In our recursive formula, we have to state what that first term is, and then show that we would take whatever term we're finding, its term before it, and then use our common difference, adding 4 each time.